Hey everybody. Today we're testing more series for convergence using the ratio and root tests. Here are the two problems we're going to do. We're not told what test to use on either one of these. We have to figure that out for ourselves. Problem 1. Sum from n equals 2 to infinity n squared over the natural log of n to the nth power. This looks like a good candidate for the root test. I see that denominator has an nth power. When I take an nth root, that's going to cancel. Let's give it a try. Limit n to infinity of the nth root of the absolute value of the general term. The absolute value is immediately going to go away. Everything inside there is positive. We don't need the absolute value. Then I'm going to take the nth root of the top and the nth root of the bottom. I want to rewrite that numerator slightly. N to the 1 over n, all of that squared. The reason I'm doing that is that the limit as n goes to infinity of n to the 1 over n is known to us. It's just equal to 1. The numerator is going to 1, and of course the denominator is going to infinity. Natural log of n goes to infinity as n does. Overall, this limit is going to be 0. By the root test, since the limit of the nth root of the absolute value of an is less than 1, the series converges absolutely, and therefore it converges. Problem 2. Sum n equals 1 to infinity n to the third times 5 to the n over n factorial. I could try the root test on this as well, but I think this is a more natural, it's more natural to use the ratio test here. I'm going to get a lot of cancellations. I'm going to get different exponents on the 5. Those are going to give me some cancellations. And the n factorials are also going to have a lot of factors in common that'll cancel. Let's actually go through the details. So the ratio test says to take the limit as n goes to infinity of the absolute value of adjacent terms, an plus 1 over an. So I start by plugging n plus 1 into the formula, and then divide by the formula with just an. I'm going to do that division by multiplying by a reciprocal, and then I'm going to start canceling stuff. Of course, on the top, I've got 5 to the n plus 1. On the bottom, I've got 5 to the n, so I've just got one factor of 5 left in the top. And then the n plus 1 factorial on the bottom, the product of the first n plus 1 numbers, is going to cancel a lot with the n factorial on the top, the product of the first n numbers. Overall, I'm left with the limit as n goes to infinity, 5 times n plus 1 to the third over n plus 1 times n cubed. Of course, a factor of n plus 1 cancels, and I'm left with 5 times n plus 1 squared over n cubed. So that's going to be an infinity over infinity indeterminate form. I need to do a little work on it. For example, I could use L'Hopital's rule, or I could end up factoring out an n squared from the top and bottom. Regardless of what I do, I'm going to get 0. So the ratio test says that if the limit of the absolute value of the adjacent terms comes out to be a number less than 1, then the series converges absolutely. As in this case, the series converges absolutely, so it must converge.